You're watching the New Stack Makers, a podcast for people who develop, deploy, and manage at-scale software. For more information and articles about at-scale technologies, please visit thenewstack.io. Now enjoy the show. Hey everyone, welcome to another episode of the New Stack Makers. I am here today with Justin Hutchings, Director of Product Management at GitHub. Hey Justin, how are you?
Great. How you doing, Alex?
I'm awesome. I saw you at the Cloud Native Security Con event, and we were chatting with Chris Anichik of the CNCF, and that was an interesting event for me because after a while, everything kind of starts sounding the same, right? But one thing that I did get out of it is a better understanding of SBOMs. And since then, I've done a little research, and I wanted to ask you just a few questions just for basics, for primers. First of all, what is an SBOM? What is this software bill of materials, just for people out there who may not be so familiar with the concept?
Yeah, it's funny. Software bill of materials files are a thing that have been available and being worked on for many, many years now. But they sort of came into sharp focus when the Biden administration released an executive order around securing the nation's cybersecurity. And in that, they required for the first time that organizations that sell to the U.S. government provide a document that tells the government what's inside. And this was really in response, first to the big problems that we saw with SolarWinds when that
Right.
particular cybersecurity incident was going on. But then, of course, just a year later, we got the Log4j incident, and every single security practitioner on the planet was scrambling to figure out what they depended on. And so fundamentally, a software bill of materials is a file that is intended to tell you, the consumer of software, what's inside so that you can kind of know whether there's a security problem later on and patch it without even necessarily having to go back to the vendor.
So how do you define what's inside?
Well, that is a really interesting challenge because every software package is different, right? So if you're talking about, an app for Android, for example, you've got the app code. There's a certain amount of that the developers wrote themselves. But then there's a whole bunch of open source that they are using. And that's probably in the form of Maven packages, things that open source developers have made and published. And, that app depends upon all of those dependencies. And so the idea of the software bill of materials is it's a full machine-readable listing of all of that stuff that app depends on, so that you as the consumer can rely on that and, make your own decisions about whether it's secure or not.
So make your own decisions whether it's secure or not. That's that's the connection. So why have they connected software bill of materials to that? Because would a vulnerability show up in that software bill of materials?
The software bill of materials itself generally won't include vulnerabilities. What they ought to include, if they're good ones, and candidly, most of them aren't, what they ought to include is a machine-readable identity for the software that lives inside.
Right.
So that means identifying the app as well as identifying the software dependencies inside the app.
Right.
So in that example I gave of an Android app, you're going to have a number of Maven dependencies, and those can be described in a machine-readable way so that this is Log4j version 2.0.0. And that's a thing that is a well-known sort of identifier that you could go and then check against a vulnerability database to see whether there are any known issues with that. But this is sort of the dream world. We're, broadly speaking, not there yet, because most of the SBOMs that are being created aren't fully machine readable, and frankly, the vulnerability data out there is in an even worse state.
Yeah, I saw an interview you did on DevOps.com with Alan, and you made this remark, and led to my question about SBOMs overall. From what I got from what you said, Alan, is like not all SBOMs are machine readable,
Right.
nor are they actionable,
Yeah.
nor are they cataloged. So tell me about the current state of those SBOMs, what we need to do to make SBOMs more than just a checkbox.
Yeah. There are a lot of things that need to happen. I mean, First of all, there are a lot of software languages where actually interrogating what's inside the build is incredibly difficult. I was picking on Android first because, that's actually a place where it's pretty good. But if you're writing, say, desktop software in C and C++, if you're an operating system vendor, for example, there's not a centralized distribution point for dependencies in C and C++. Most developers actually download those dependencies and check them into their code. There's not a standard way to go and enumerate those and have strong names and strong versions. And so when you look at a lot of the SBOMs that are out there, they actually don't have a good way to resolve machine readable names for those. And this is a problem that we need to deal with across the entire software supply chain. When you go and run a build to build a piece of software, it should be automatic that you get a useful SBOM. But so many of the spots that we have are just not quite there yet. A lot of the tool chains are not actually giving us what we need there.
So when they're not giving what you need there, like, give me an example.
So yeah, basically, if you go and run a build with make, that's the tool that you would use for C or C++ builds. At the end of that build process, you don't get an SBOM. And so anyone that provides you an SBOM based on a C and C++ project is making it after the fact. They're either making it by hand or using a tool that is going to make guesses as to what's actually inside.
Oh. Oh, this is a weakness in C and C++ then too.
It is. Yeah, absolutely. Absolutely. So every vendor out there that builds with C and C++, they're actually reporting on things after the fact. The tooling is not native by any means. And so, we need to go all the way back to like the GNU C and C++ compilers to go and have those compilers understand what they're linking in and build those SBOMs. And that's just one language. Every single programming language has slightly different characteristics on this. So if you as an end consumer or company that are buying software or trying to make sense of a software bill of materials, you've got to understand that the level of quality and sophistication on the data you get is going to vary dramatically based on what tools actually went into building the thing.
That's a angle we discussed today in a conversation I had with my editor-in-chief, Joe Jackson. We were talking about C and C. Well, we were talking about C++ in particular, and how even it's coming to the point where university professors don't know where to start and how to teach teach about C++ because it's so vast. And then you kind of multiply that by multiple by multiple languages, and then it's just become such a problem. How did we get here? How come we weren't doing this years ago? And like, why is it a crisis now? I guess it's SolarWinds and the other attacks, but what was going on in those past years?
Well, I mean, the big transition that's really happened across software security over the last, say, 15 years, it's been the pivot towards open source. 20 years ago, if you were writing an app, you were probably building most of the nuts and bolts yourself. Whereas today, the availability and quality of open source libraries means that most folks are including open source for a lot of the stuff that they do. It allows them to focus on the things in their app that they really appreciate, the things that make their app unique. But there's a cost. Cost is suddenly you have to not just do the security assurance on your own code, you also have to monitor and patch all of the vulnerabilities in the code that you've brought in through open source. And really, the pace of bringing in open source ran well ahead of the pace of building out the security practices to secure it properly and respond to challenges that happen as after you've brought that software in.
Yeah, that is the big deal. So let's turn to GitHub. And what were the first tools that GitHub offered for SBOMs, and why did you start offering them?
It's a good question. I mean, if you go back to the sort of genesis of GitHub doing software security, we actually had back in 2017 is when we first started doing alerts for vulnerable dependencies. And it's before anyone wanted to call anything an SBOM. But as we've been evolving and tracking towards helping folks consume open source securely, folks are asking for an export of a software bill of materials. And that's a thing that's pretty easy to build from our APIs. So we've got various examples out there on how you go and pull that from the API and build out an SBOM. But most folks that are asking for it are just trying to tick a compliance tick box. They
Hmm.
actually don't think it's going to improve their security outcomes.
Mm.
And so, for better or for worse, we've actually been focused primarily on the security workflows that we've got for developers. So we think it's a higher leverage point than giving the compliance team a JSON file that they can sort of stuff in a folder somewhere.
Hmm. How did you come to that
I mean, we've
realization?
got we've got a ton of customers using Dependabot and our other software security tools. And so, we hear feedback from these folks all the time about what are the things that they expect. One of the things that we do with Dependabot is we offer automatic remediation.
Can you tell us
Uh,
a bit about what Dependabot is?
yeah. Dependabot it's sort of an overused brand name, but Dependabot is at its core our software supply chain solution.
Okay.
And so we use that to monitor your dependencies, alert you if there are vulnerable dependencies, and then automatically remediate vulnerable dependencies. And this gives developers a much faster path to go and respond to threats in their own code as they're writing it. GitHub, of course, being a development platform, we optimize all of our experiences for the developer experience, for the workflow that developers are in when they're building and maintaining their software. And so that's fundamentally been what's continued to drive our investment is meeting developers where they are with tools that are friendly and native to development teams, not security teams.
Okay. So you have 100 million users out there, thereabouts. And, every one of them, may create X number of repositories. I'm sure you guys have some idea on that. What are you trying to do with developers themselves to help them get in the routine of being cognizant of the software supply chain, of their security workflows? Dependabot seems like something that you're asking people to use. Maybe you could tell us about the momentum behind Dependabot, how they're using it, what they're using it for.
Yeah, I mean, it's important to think about just the scale at which GitHub is operating. We've got 100 million developers, and we see on the order of 85 million new repositories every single year. And not every one of those repositories is a thing that people really care about, right? If you've built code on GitHub, you've spun up a random project, you've checked in homework, you've done something that's throwaway. And so not all of those, do we encourage folks to turn on security features for? Because a lot of it's just sort of, for funsies. But we work really closely with the open source community and with enterprises on getting folks to go and make use of Dependabot as well as our other software security capabilities. Because fundamentally, we believe that it's our responsibility to help protect developers from the threats that are out there in open source. So we give away literally every one of our capabilities on security to open source developers for free, and we've seen a lot of adoption. And I don't have the numbers handy right this second, but folks use these things to go and prevent vulnerabilities from ever making it into their code. They also go and use them to respond to threats as they happen in open source.
So those are the developers using these free tools.
Yeah.
What about the paid tools? Are there enhancements you provide too for better security postures?
There's a couple of additional things. Most of the capabilities are the same for open source as they are for enterprises. We've got some special experiences for enterprise security teams
Hmm.
around managing vulnerabilities at scale. So developers are usually dealing with one repository at a time, but we know security teams want to know, hey, tell me about all of the instances of Log4j across my entire organization. So we've got some experiences that help them manage those things at scale.
Okay. Any any themes you see coming up with developers, like patterns that you're seeing in their repositories in terms of how they're adopting these open source security tools?
It's a good question. The thing that we've seen sort of the fastest adoption on recently is actually a new beta that we released back in the fall, which is called private vulnerability reporting. So you may be aware, um, one of the challenges that open source developers have is dealing with security researchers. Security researchers are obviously very interested in getting CVEs and helping make the world a safer place. Um, and most of these projects had a security at, whatever inbox, where they would get emails from various folks who were seeking to disclose vulnerabilities. And we heard from a lot of these developers that that process was painful. They had to have a special email inbox, they had to monitor it. They got spam there because, of course, they did. And it was just really an unpleasant experience. And so we released an integrated reporting experience inside GitHub back in the fall. And we've seen tremendous adoption on this. And the reason is, everyone wants to do the right thing. They were just looking for tools that made it easy to do so. And that's been a really great experience for the developers, and we've started to see some of our first CVEs coming through that. I want to say we've issued around 10 CVEs already through that private vulnerability reporting channel, which is a slow but really reassuring start.
Hmm. Is that going to be key, do you think? Where do you see us in a year from now?
I think it's going to keep growing. What we see is obviously security vulnerabilities. You can't predict when they get disclosed or what have you. But we've seen a lot of really exciting projects adopt that already. So, whether that's the Electron project, Homebrew, the Cloud Native Computing Foundation, these are the sorts of folks that are looking for these sorts of capabilities to manage disclosure so that they can actually stay on top of the vulnerabilities as they come in, because it can be a full-time job to deal with vulnerability reports. And these tools so far have made it a lot easier for folks.
What's the what's the kind of core architecture of these tools?
Everything that we have at GitHub is integrated natively in the repository. So we've got a security tab that all of our alerts show up in. And so things are really natively integrated. We've also got experiences where we can prevent vulnerabilities from ever making it into your production. So we can, with our secret scanning product, we have a feature called push protection, where if you checked in a secret, when you hit get push, we'll actually push the push back to you and say, I'm sorry, that's blocked. We found a secret. You need to resolve that first. And so, we've done what we can to sort of meet developers where they are in the development workflow to make sure that we're really reducing as much friction as we possibly can.
Reducing as much friction as you possibly can. So what are you asking developers to do? What is it that they should be responsible for?
That is really a huge question. It's going to vary, between open source and enterprises. But broadly speaking, the goal that we have is to reduce the amount of energy that developers have to put in to managing vulnerabilities. And so, step one is if you haven't thought about security at all, go to one of your GitHub repos, go to your security tab, and there's an experience to enable all of the features. So turn on Dependabot, turn on code scanning, and turn on secret scanning. Those 3 buttons there will get you a tremendous amount of insight about the vulnerabilities in your code, the code you depend on, and whether there are any secrets that you've checked in. Just getting those things turned on is going to make the biggest difference in terms of your security posture. And all of those are free for public repos. And if you're an enterprise, we'd love to talk to you about what you can do to use those.
Let's list those again, because that's really important. Can you list those 3 again?
Absolutely. So we've got Dependabot, which is the tool that we
Yeah.
have that secures your dependencies.
Yeah.
Secret scanning, which kind of does what it says. It looks for secrets that are checked into your code.
Okay.
And code scanning, which looks for vulnerabilities in the code that you've written yourself.
Thank you very much.
Of course.
Now, I asked a question on Twitter and you saw it, and it was interesting. And Liren Tal, who's with SNCC, I asked about conventions of usage because I saw this come up in another conversation with Gareth Rushgrove, and 2 very smart people who I know and I really like, and I appreciate their commentary. And Liren said, I would assume this is anything from recommended, and he's talking about conventions of usage. I would assume this is anything from recommended file naming conventions, serialization format, to artifact location source to be consumed or referred to. For example, it's a convention to place license files at the repository's root and they are referenced from GitHub sidebar links. Is that an example of what you think needs to evolve in terms of conventions of usage? And perhaps you could provide some commentary on what Liren has said.
It's a really interesting question. One of the things that I think is really important to think about is what's the eventual end state we want for software bill of materials. And when I think about that, I think about software bill of materials being a really useful exchange format. And so I want to get to a point where if I go run make for my C or C++ app, if I go and run, the Java build tool or any of these other products, when I build that, I want an SBOM to drop out of the build. So, if your build goes into a bin directory, there should be an SBOM right next to it. And frankly, it doesn't matter particularly where it goes right now. There are some well-known formats that exist out there, and folks are using naming conventions. So, with an SPDX formatted SBOM, folks are using the extension .spdx.json. That's fine. That's all I need to go and find it as a security tool is a naming pattern like that. And so working, I'm through the OpenSSF, we've been talking about what we can do as an industry to go and influence the open source tool chains that everybody relies on to make it so that the security artifacts drop out by default. And I think that's one of the highest leverage things that we as an industry can do is go and get these interchange formats dropped out of every build tool so that every developer has access to this without going and doing something special. Once we've got those dropping out, then we can figure out all the additional workflows on where should we put them? How should we alert on them over time? How do we store multiple versions side by side? All of those are really good conversations that we definitely need to get to. But most organizations are struggling just to produce these things at high quality consistently.
Is this an opportunity for, more automated capabilities to scan the code and create SBOMs on the fly? I guess the question is the verification and authentication. Because then you could one of the most difficult things I've seen just as a journalist is like file naming conventions, right? I think it's difficult for everybody, right? Is there capabilities to auto complete file naming conventions? Is there, can some of these problems, I'm sure some of these problems might be able to solve through automation capabilities.
Yeah. I mean, certainly there are a lot of folks that are building tools that go and do that.
Yeah.
But I think the highest leverage point is to actually put them in the upstream tools for people that are building software. Most software requires compilation or build or something along those lines. And, by putting that into the build tools themselves, that gets you sort of access by default, where you can actually change the default behavior and not require developers to opt into a behavior. That's where you're going to start to get the biggest lift.
That's interesting. And that makes sense because your focus is on building tools, right? I mean, that's kind of essentially what you help developers do.
Yeah.
So I was going to ask you about the other advances in security, alerting, and tool threat detection capabilities that are needed. Anything that pops to mind quickly? Because then I have a last question. And I know you know what it is, but any thoughts there? Just that you think are important for developers to understand some of the advances that we're starting to see?
I mean, one of the things that's really interesting is developers are, going through as much as the transition between pre-open source and open source development changed the security landscape. A lot of developers are also going through the cloud transition as well. Many organizations are ahead and are already running in the cloud, and they're using infrastructure as code or containerization or any of those things. And that is a thing that every organization needs to be thinking about as well is, do I know not just what's in my app, but what's in the software that I run on? Because that is actually an entirely different space. It's a little bit orthogonal to looking at your own code. You're looking at the operating system. You're looking at what things are installed on the computer that I'm running on. And it's not a fun space right now. If you go and run most container scanning tools or most tools that look at what's on the operating system, you're going to get back hundreds or thousands of CVEs on
Yeah,
most of the images that are out there.
it's crazy.
And it's a scary time.
Yeah.
And, we as a security industry need to do better about making those things more secure by default.
Yeah, and it's spilling over into consumers day and night, and that's rough. Like
Yeah.
for my last question, my favorite question these days is about WebAssembly. What about WebAssembly? We're hearing it talked about as a security solution.
It's an interesting idea as a security solution, but fundamentally I look at WebAssembly as basically just, extending your web technologies to other programming languages.
Mm-hmm.
And as much as that changes your threat model, if you're worried about how many dependencies you have in JavaScript, if you write your thing in WebAssembly using Java, well, that changes your threat model. But in my opinion, it makes it bigger, not smaller.
Mm.
You know, anytime we're talking about expanding the number of technologies that are in place to get a job done, you've got more surface area that you need to monitor for security problems. And, I think in a world in the future, WebAssembly makes it a lot easier for developers to be more productive and to build things in the tools they're most comfortable with. But it means as well that we're going to have to develop new security capabilities to make sure that we are covering all of the new usage scenarios that come out of, taking what are historically desktop oriented languages and throwing them on the web for various purposes.
Justin, thank you so much for taking the time. I've enjoyed the conversation. I've learned a lot.
Absolutely. Thank you for having me today. It was great to chat.
If you like this video, please give us a thumbs up. And if you'd like to see more videos like this, you can always subscribe to our YouTube channel. We're on all the major social media platforms. You can always find us at thenewstack.io. We hope to see you soon.